In this lesson, we'll continue our discussion of muscle tissue by taking a look at muscle performance. So there's really two things we look at when we look at muscle performance. One we actually studied already in previous lessons is force, which is basically the maximum amount of tension that is produced, right? So we looked at how different muscles produce tension. The other factor is endurance, and basically this is the amount of time that an activity can be sustained. So both force and endurance are going to depend on two things. We're going to take a look at three different types of muscle fibers, right? So far all along in the lessons, I've kind of had you assume that all muscle fibers are the same. It turns out there's not. We have three different ones. And then the other factor is going to be physical conditioning. That's going to determine also force and endurance, right? Those of you that work out, right, know that you could probably do more weightlifting than say somebody that doesn't, or somebody that's a runner, right, that they can run longer distances than somebody that can't. So physical conditioning is definitely going to be a factor. So as I said, up till now, I've let you assume, kind of give you the impression that all muscle fibers are the same. It turns out they're not. There's three types. We're going to break it down very simply as fast, slow, and intermediate fibers. Let's take a look at the fast fibers first. These are the majority of the skeletal muscle fibers. These fibers have the ability to contract very, very quickly, hence the name fast fibers, right? They can actually break down ATP rather rapidly. If you were to look at them under the microscope, they are the biggest fibers. They have the biggest diameter. They're pale in color, and one of the reasons they're pale is because they store a lot of glycogen. They don't have a lot of mitochondria. So if you go back to our previous lesson, when you break down glycogen and you're not using a lot of mitochondria, we're predominantly relying on glycolysis, which only gives us 2 ATP. So that means we're going to be able to do some heavy work. The problem is these are going to fatigue very, very quickly because they don't have a lot of mitochondria, right? They're relying on glycolysis for um, their contraction. So these can actually produce very strong, powerful contractions, but these muscles fatigue very, very quickly. And again, if you just tried something like this, let's just say you went to do like a bench press or something like that, and you said, hey, you know what? I want to do like, 7 reps, but a much heavier weight than I'm used to, right? So you may be able to do the first, like, 1, 2, 3, and then at number 4, you're starting to struggle, right? It starts to get harder and harder. Those are the muscle fibers that you use, right? They're able to do the heavy work, but they fatigue really, really quickly. Now, they're all over the body, but they tend to be in higher amounts in the upper limbs, right? These are actually the fibers that when you work out and you want to look bigger, right, you want to bulk up, we call that hypertrophy. These are the fibers that actually get bigger. Okay, so what you need to know is that these contract very, very quickly. They're the biggest in diameter, right? They're pale under the microscope. They don't look like a reddish color. They look more a light pink type of thing. They're more on the pale side. Um, they have a lot of glycogen that we use for fuel, so that means the main uh, source pathway that they go through is glycolysis. And again, if you remember from a previous lesson, glycolysis only gives us 2 ATP. Right? And that's why these muscle fibers don't have a lot of mitochondria. They're not using mitochondria to produce a lot of ATP. So the good news is these are strong muscle fibers, right? We can do a lot of heavy work with them, but they fatigue quickly, right? They're not going to go long. Right? And again, they're all over the body, but they're more predominant in the upper limb compared to slow fibers. So these are slow to contract, but they're also slow to fatigue. That means these can contract, throughout the day, more slowly, just kind of slow and steady, but not fatigue. If you were looking at these under the microscope, these would have the smallest diameter, and they have a lot of mitochondria. So that means, if you again, you remember from our previous lesson, when we have energy being produced by the mitochondria, we're producing a lot of ATP as long as we have oxygen going into the mitochondria. So since the mitochondria require a lot of oxygen, there's a lot of blood vessels going to these muscles here. They have an extensive capillary network, making sure that there's plenty of oxygen for the mitochondria. The other thing, these muscle fibers contain a protein that sounds like hemoglobin, but we don't call it hemoglobin, we call it myoglobin. Just like hemoglobin in the blood, myoglobin holds on to oxygen, making sure that these muscle fibers have plenty of oxygen. So, if you have numerous mitochondria, the muscle fiber has a good blood supply with plenty of oxygen being stored by myoglobin. These here, these fibers are going to be slow to fatigue, right? They'll contract all day long without getting tired. And that's good because we have them in higher proportions in postural muscles, right? The muscles that keep you upright all day long, right? You can pretty much walk around and stay upright all day long. Even sitting on a chair, you're requiring postural muscles to keep you upright. You don't fatigue, right? These muscles don't fatigue. These actually look, these muscle fibers here actually look more reddish under the microscope. The previous ones look more white. These look more reddish in color again because they have this red pigment, myoglobin. They have a lot of blood vessels, so they'll appear red. All right, so what do you need to know? These are the smaller fibers in diameter. They're slow to contract, but they don't fatigue, right? They typically don't fatigue because they have a lot of mitochondria, a good blood supply with a lot of oxygen, and this pigment protein called myoglobin, which holds on to oxygen in the muscle fiber. And again, these are found all over the body, but they're in higher amounts in your postural muscles, like your back muscles, your neck muscles, that type of thing. Here's a picture from our book. They're actually showing, so these, again, it's a little bit hard to see. It should be a colored picture, but this is actually showing white fibers. These are actually going to be the larger diameter fibers with a lot of glycogen, not a lot of capillaries, no myoglobin, where here, these are more darker red fibers. Here, the R is for red. Here's like mitochondria. They're showing the mitochondria in there. So these typically are going to be more for the postural muscles where they're not going to fatigue. Your gastrocnemius and soleus, believe it or not, these are postural muscles here. They'll tend to have a lot of the smaller, like here, smaller diameter muscle fiber, like that. And then here, this is a muscle in the eye. These are actually more white fibers, the fast fibers. See, the side diameter is much bigger. And if you had taken like a shoulder muscle, same type of thing, you would have these big muscle fibers. And again, you can see the color is more pale compared to the deeper red over here. All right, so that's just an example of, again, your slow fibers and your fast fibers. Over here, slow fibers, fast fibers, red, white. So in between, we have these fibers called intermediate fibers. These are going to be mid-sized. They have a little bit of myoglobin, not nearly as much as a slow fiber. So they're more pink in color, right? They're not really a deep red. They're more pinkish in color. And they have more capillaries than fast fibers. So they typically don't fatigue unless you push them, meaning that they'll pretty much contract, most of the day, but it's only if you were to push them that they could fatigue. These again are found all over the body, but they're in higher amounts in the lower extremities. So let's just say you're at work, right? You're walking around all day at work. You're doing your activities, right? Your legs don't fatigue, but then let's just say it's 5 o'clock. It's time to leave work, and you sprint to your car, right? You can't wait to get out of work. You sprint to your car. By the time you get to your car, your legs are fatigued, right? You pushed those muscles and they fatigue, right? So these will fatigue if you push them. Okay, so those are our three fibers: our fast fibers, our slow fibers, our intermediate fibers, right, or somewhere in between. So as far as what we have, white muscles and red muscles, think about a chicken for a minute or a turkey, right? If you want white meat, you basically would have like chicken breast. So think about this for a minute. White meat is going to be mostly fast fibers because we said the fibers are white. Why would a chicken breast have white meat? Think about it. Our chest muscles, the breast muscles, control, in the case of a chicken, the wings. When a chicken doesn't really fly around, right? They may flap their wings to scurry about real quickly. They'll flap their wings for a short period of time and then they stop. The reason for that is they have these white fibers. You don't see chickens flying long distance, right? So they're going to have white fibers on the chicken breast. But chickens walk around all day. Their leg muscles are their postural muscles. And you can watch chickens, right? They just kind of walk around all day, looking for food. They're on the grass, they're on the dirt, that just kind of thing, walking around. The reason their leg muscles don't fatigue is because they are slow fibers. So we said that slow fibers are red. Right? That's one of the reasons a chicken leg is dark meat. Okay, it's going to have more myoglobin, more blood vessels, that type of thing. So that's more dark meat. All right. So again, the chicken breast is white meat because it controls the wings. And again, a chicken does not fly long distances, right? They just flap their wings quickly. That's probably because they fatigue, right? And that's why the chicken breast is white. And the chicken legs are their postural muscles. In humans, like I said, all three muscle types are in all of our muscles, so that our muscles tend to be more pink. We don't really have white meat. We don't really have red meat. We have a combination of all three muscle fibers, so our muscles in reality look more pink in color. So let's talk about this. Our muscles can get bigger or smaller, right? When a muscle increases in size, we call that hypertrophy, right? So if you go to the gym to bulk up, right, to make your muscles look bigger, you're actually doing hypertrophy. So this is muscle growth from heavy training that causes an increase in the diameter of the muscle, right? That makes you look bigger. The number of myofibrils, right? Those are the bundles of the myofilaments, the actin and the myosin, right? They get more. You increase your mitochondria, and you also increase your glycogen reserves. So this all here makes you look bigger. Just the opposite, if you don't work out, let's say somebody decides they want to become a bit couch potato, right? They're more complacent. Their muscles will get smaller, so there's a reduction in the muscle size, the muscle tone, and even the amount of power that we generate. And this is known as muscle atrophy. Right? So hypertrophy, our muscles get bigger. Atrophy, the muscles get smaller. Now, as we get older, our muscle tissue changes also. Generally, our skeletal muscle fibers become smaller in diameter. The fibers become less elastic. If you ever kind of like just kind of feel the muscles of somebody older, you kind of like say massage the top of their shoulders, you actually feel like scar tissue. It becomes very, very ropey almost. That is known as fibrosis. That's an increase in the amount of fibrous connective tissue. And instead of just the muscle having a nice smooth suppleness to it, it actually feels more like scar tissue, believe it or not. So we call that fibrosis. As we get older, our tolerance for exercise decreases, especially if somebody's like a couch potato and they're older. They don't do well doing that exercise. They can't do it as long, so it's important to try to be as active as possible as we even get older, so you can tolerate the exercise a little bit better. And then also the ability to recover from muscle injuries is not as fast as when we're younger. Okay. So I mentioned this a little bit in a previous lesson, something known as muscle fatigue. When muscles can no longer perform at a required level, right? You want to work out, you want to keep going, they are considered fatigue. So what are some of the things that cause muscle fatigue? How about this? We deplete our metabolic reserves, right? We burn up all of our glycogen, use up all of our fatty acids. Maybe the exercise we do damages the sarcolemma, which is the cell membrane of this muscle fiber, or the SR, the sarcoplasmic reticulum that stores the calcium. Um, our pH goes down and our muscles become more acidic as we work out, right? We start to accumulate hydrogen ions. We start to accumulate lactic acid. That affects the ability of calcium to bind. All right, so that's going to affect muscle performance. And then again, even just pain. Sometimes when we're in muscle pain, the central nervous system, our brain and spinal cord may just say, hey, you know what? Enough is enough, and it causes the muscle to fatigue. Okay, so even though you may want to physically go on, um, the muscle will, shut down, just to kind of protect itself. Okay, just the last couple things about muscle performance. Let's take a look at physical conditioning, right? Conditioning can improve power and endurance. So far we've looked at the muscle fibers, how they can affect, power and endurance. Now we want to look at conditioning. So if you do anaerobic exercises, these are going to be, again, short exercises, short periods, but that are more intense, maybe like a 50-meter dash, right? You're kind of going all out for 50 meters, or you do some heavy weightlifting. These are going to involve activities that use fast fibers, and that stimulates the hypertrophy. So that stimulates you to get bigger. Okay. The way you do that is by frequent, brief, intense workouts, right? So you're going to bulk up by doing more frequent, brief, and intensive workouts. Opposed to if you do aerobic exercise, right? Aerobic endurance, which is more prolonged activities, maybe running on the treadmill, the elliptical, right? Brisk walking for a longer period of time. These activities are supported by the mitochondria, and typically they don't stimulate hypertrophy, right? So if you want to bulk up, this is not the type of exercise that you do. And think about it, if you look at runners, right? They're typically not, they don't really have big muscles. They have nice toned muscles, right, that are kind of like more normal size. They're not really big. That's going to be because they're doing these aerobic activities. So this involves more sustained, right, longer periods of time, but not intense, heavy exercise, right? More just longer period of times, more lighter weight, let's say. Okay, and what are this you probably know already, right? What are the overall effects of doing endurance exercises and just training in general? It's going to produce improvements in aerobic endurance from alterations in the characteristics of muscle fibers. So again, it can change the way your muscle fiber actually is, right? It's going to make it healthier, but also it improves cardiovascular performance, right? So aerobic endurance is really good for your muscle fibers, and it helps not only to help your muscles, but it helps your heart and even your lungs for that matter. Okay, so that concludes this lesson on our different types of muscle fibers and also training.